The operation of half wave rectifier completed. Now we need to calculate all these characteristics. We have totally 6 characteristics are there. First one is efficiency, ripple factor, peak inverse voltage, transformer utilization factor, peak factor, form factor. So efficiency means is the capacity, how much percentage to convert AC signal to DC signal. Ripple factor is unwanted AC signals which will be present at the output signal. Peak inverse voltage is the maximum reverse voltage before the breakdown condition. Next, transformer utilization factor. How much capacity we used transformer in half wave rectifier and full wave rectifier. Next, peak factor, form factor. So first one is efficiency. So before going to calculate these characteristics, so first we need to find out average DC value and RMS values of output voltage and output current, input voltage and input current. Before going to calculate all these characteristics, first we need to calculate average DC value and RMS value of the voltage and current. So first average DC value. First we need to find average DC value, right? We calculate current value. After that we can calculate a voltage value, right? So here average current is the output current, is at the output of the rectifier, that is IAV. We know output voltage or output current is in DC form, so that is why IAV, average current, is equals to IDC, DC current, that is equals to, formula is 1 by 2 pi integral 0 to 2 pi I naught d omega t, right? So here we are taking the output is from 0 to 2 pi. 0 to 2 pi means this is the input signal and we got the output signal like this. X axis is omega t, time period. Y axis is input voltage for output signal V naught. For input signal Vi, output signal V naught. So here we are taking the limits from output, for output voltage and output current, we are taking the limits from 0 to 2 pi. 0 to 2 pi. So that's why we are taking the limits from 0 to 2 pi. 1 by 2 pi integration, the limits from 0 to 2 pi, we got the output current, that is I naught d omega t, right? Next, this is the formula. Next, 1 by 2 pi as it is. Integration 0 to 2 pi. So here I naught. We know the value of V naught and I naught. V naught value is V naught equals to Vm sin omega t. I naught equals to Im sin omega t. Simply, instead of I naught, I am writing like Im sin omega t, t omega t. Next, so here I am expanding this limits 0 to 2 pi, right? 0 to 2 pi is expanding like 0 to pi, pi to 2 pi, right? So that's why 0 to 2 pi, from 0 to pi, pi to 2 pi. So 0 to pi during positive half, we are getting the output, right? We are getting the output. So that is why from 0 to pi, Im sin omega t d omega t. Next, from pi to 2 pi, we did not get any output. We did not get any output. So that is why 0 d omega t. Simply, we are expanding this limits 0 to pi, 2 pi as 0 to pi and pi to 2 pi. 0 to pi, we are getting the output. That output current is, formula is Im sin omega t. But pi to 2 pi, we did not get the output. So that is why we are taking the 0. Next, This Im is the constant current. So that is why Im is taking outside Im by 2 pi. Okay, after taking Im is at output, then remaining term is sine omega t d omega t. So next term, second term is integration of 0, the total term is 0. Right? Okay, next Im by 2 pi. Integration of sine omega t. Integration of sine omega t formula is minus cos omega t. So that is why integration of sine omega t formula is minus cos omega t. And also we need to apply the limits from 0 to pi. Next, this minus, I am taking this minus is at output side. Then remaining term is cos omega t. So for this cos omega t, I am applying the limits. We know first we apply upper limit minus apply lower limit. So cos pi minus cos 0. Okay, next. So after this equation minus Im by 2 pi as it is. Next, cos pi value minus 1 minus cos 0 value 1. In next step, minus 1 that is minus 2. So minus Im by 2 pi into minus 2. This minus we got plus and 2 gets cancelled to each other. The finally we got I naught is equals to Im by pi. I naught which means average current formula IDC equals to Im by pi. Similarly, average output voltage value VDC equals to Vm by pi. Okay, note it down all the equations up to here. So we calculated average current and average voltage. So average current formula IDC equals to IDC average current IDC equals to Im by pi, VDC equals to Vm by pi. Okay, and next we have to calculate RMS value of voltage and current. So here average current and average voltage means like we are taking in terms of output voltage and output current equations. Now RMS value is calculated for input voltage and input current, right? So here first VRMS formula. RMS means root mean square. So that is why we are taking a root mean square. So this is the formula. Take it as star mark. VRMS equals to under root 1 by 2 pi integral 0 to 2 pi V naught square d omega t. D omega t means we are taking the integration with respect to omega t. Right, this is the formula of RMS value of input voltage. Next, simply we are simplifying this equation. Next equation is simplifying this equation. VRMS equals to under root 1 by 2 pi as it is integral 0 to pi. So here V naught formula, we know already V naught formula is Vm sin omega t, I naught formula Im sin omega t. So that is why instead of V naught we are taking Vm sin omega t. So here we have a square, right? So that is why Vm square sine square omega t d omega t. Okay. So in next equation here Vm is the constant term. Vm is the constant term. So that is why I am taking outside of the integration part. So Vm square by 2 pi integral 0 to pi and the remaining term is sine square omega t d omega t. Right. In next equation, under root Vm square by 2 pi as it is, integral 0 to pi, sine square omega t formula. Sine square X formula. What is that? 1 minus cos 2x by 2, right? So here also same, sine square omega t formula is 1 minus cos 2x by 2. Sine square x formula is 1 minus cos 2x by 2, right? So that is why sine square omega t formula is 1 minus cos 2 omega t 2 by 2 t omega t. Okay, next Vm square by 4 pi under root Vm square by 2 pi is as 4 pi. Why? Because this 2 is taking outside, 2 into 2 4 pi. Okay. So after taking this denominator 2 is at output side, the remaining terms are 1 and cos 2 omega t. So you have to integrate first 1. So that is why integral 0 to pi 1 d omega t. After that, second term is integral 0 to pi, second term cos 2 omega t d omega t. Okay, right. Next step is Vm square by 4 pi under root Vm square by 4 pi as it is. Okay, right. So integration of one formula is x. If we integrate with respect to x, formula is x. So here we are integrating with respect to omega t, right? So that is why integration of 1 is omega t. So after taking integration, have to apply limits also 0 to pi. Next, integration of cos 2 omega t. Integration of cos x formula is sin x. Okay. So here integration of cos 2 omega t formula is sin 2 omega t. Again we need to integrate 2 omega t formula, that is 1 by 2. So total cos 2 omega t formula is sin 2 omega t by 2. So after taking integration, need to apply limits from 0 to pi. Right. Next, Vm square by 4 pi as it is. So applying limits, first you have to apply upper limit minus apply lower limit. So pi minus 0 minus as it is. Again same, apply first upper limit, after that lower limit. Sine 2 pi by 2 minus sine 0, right. Next, under root Vm square by 4 pi, pi minus 0, that is pi, minus sine 2 pi formula, sine 2 pi formula is 0, right, minus sine 0 formula, sine 0 formula is 0. So that is why sine 2 pi, this pi as it is pi and this total term as 0. Sine 2 pi value is 0, sine 0 is value is 0. So that's why this total term as 0. Next, Vm square by 4 pi as it is, pi minus 0 as pi. So pi gets cancelled and the remaining term is under root Vm square by 4. Right? So Vm square by 4 which can be written as Vm by 2 whole square. So square root to cancel, then we got finally Vm by 2. The current formula is Im by pi. DC voltage formula is Vm by pi. As well as we calculated VRMS value. VRMS value is Vm by 2. Similarly, IRMS value is Im by 2. Okay, so first we have to calculate these terms. After that, we can go for all these. Okay, so we'll go for a calculate first term as efficiency. Statistics already we find out VDC, IDC, average values of voltage and current, RMS values of voltage and current, right? Now we'll go for efficiency. Efficiency is equals to, the formula is the ratio of DC output power to AC input power. right? So DC output power is a PDC by PAC. The efficiency formula is a PDC by PAC. Output DC output power by AC input power, right? And again PDC formula is a VDC square by RL. Okay, PAC formula VRMS square by RL. Already we find out VDC and VRMS values. VDC value is Vm by pi, VRMS value is Vm by 2. Simply instead of VDC we are taking Vm by pi whole square by RL. Here Vm by 2 whole square by RL. So finally we got Vm square pi square Vm square by pi square RL. So from here Vm square by 4 RL. Okay, we calculated DC power and AC power. After that these two values substitute in meter, PDC by PAC. Simply substituting these two terms in numerator and denominator. Okay, Vm square cancel, RL cancel, and the remaining terms 1 by pi square by 1 by 4, that is like 4 by pi square. 4 by pi square value is 0.406. So in terms of percentage, that is a 40.6 percentage. So here we got efficiency value is a percentage of efficiency is a 40 percentage in half wave rectifier. Only 40 percentage of signal is converting from AC signal to DC signal. So that is why this half wave rectifier is does not used in the practical way. Characteristics is a ripple factor. Ripple factor is a unwanted AC component present which can be present at the output. Formula of ripple factor, that is a gamma equals to ratio of RMS value of AC component to DC component. So the ratio of RMS value of AC component to DC component, that can be gamma equals to VR RMS by VDC. So the formula is a VR RMS by VDC, right? And again RMS value of AC component formula, that is VR RMS equals to, this is also formula, VR RMS equals to under root VRMS square minus VDC square. Okay, substitute this term RMS value of AC component, that is VR RMS is substitute in this term, then gamma equals to under root VRMS square minus VDC square by VDC. Okay, after taking VDC as common, then after simplification, then VRMS by VDC whole square minus 1. Okay, now we need to substitute the values of, we know already formulas for VRMS and VDC. VRMS formula is a Vm by 2, VDC formula is a Vm by pi. Okay, we got a gamma equals to under root VRMS by VDC whole square, right? So gamma equals to under root VRMS by VDC. VRMS is a Vm by 2, right? So Vm by 2 by VDC. VDC value Vm by pi. Vm by pi whole square minus 1. Okay, right? So Vm gets cancelled. Then the remaining terms are gamma equals to under root 1 by 4 by 1 by pi minus 1. Okay. So finally we got okay, after this simplification we got pi by 4 minus 1. Sorry, 1 by 4 here, pi square by 4 minus 1 under root pi square by 4 minus 1. This total term is a 1.21. 1.21. So the ripple factor is a 1.21. In terms of percentage, 121 percentage of unwanted signals are at the output side. Unwanted AC components are present at the output side. So that for this reason also, due to this reason also, we cannot use the half wave rectifiers in the practical section. And the next term is a peak inverse voltage. Peak inverse voltage is, what is mean by peak inverse voltage? The maximum reverse voltage before the breakdown voltage. Maximum reverse voltage before the breakdown voltage. Actually we are giving the voltage as Vm, right? So peak inverse voltage value is PIV equals to Vm. Okay, next, transformer utilization factor. So here transformer utilization factor value, transformer utilization factor of half wave rectifier value is 0.287. Means utilization of transformer in the power supply. So that is the value of TUF for half wave rectifier is 0.287. So in terms of percentage, only 28.7 percentage, 28.7 percentage we used in the power supply. After remaining two characteristics, peak factor, form factor. Okay, so here peak factor formula, the ratio of peak value to RMS value, peak value to RMS value. So peak value means maximum value of the signal, maximum voltage of the signal, that is at positive side, that is Vm, negative side minus Vm. Obviously we are taking positive side, Vm divided by Vrms. So Vm, as it is Vm, we know the formula for Vrms, that is Vm by 2. So substitute Vm by 2, then Vm get cancelled. Then we got 1 by 1 by 2. 2 is here. Then the answer is 2. So half wave rectifier, the peak factor of half wave rectifier is, value is 2. Next, form factor. Form factor value is the ratio of RMS value to average value. RMS value to average value. So that is Vrms by VDC. We know formula for Vrms and VDC. Vrms value is Vm by 2. VDC value is Vm by pi. Vm gets cancelled. Then after simplification we got pi by 2. Pi by 2 value is 1.57. Right? So this is what about all the 6 characteristics. All the 6 characteristics. You need to remember each and every value. Half wave rectifier efficiency, half wave rectifier ripple factor, TUF, form factor, peak factor. So you should remember all the values and formulas of all about this. Thank you.